Okay, let's look at what's going on as the car accelerates, then collides, and they decelerate. We have a car, and there's work being put in, and it's speeding up. If we look at the flow of energy, the work in is turned to kinetic energy. Is there any frictional losses? I say there's none, so this is an equality. So the kinetic energy at this point, let's call this kinetic energy 1, is due to the work that you put in. It's the same. And then, boom, okay, so this V0 equals 0. There's this guy sitting here, and there's a collision, and afterwards, these two guys are stuck together, moving along at some V final, and that's going to have some kinetic energy. Let's call that kinetic energy final. And then I stop. The brakes push it in this direction, and they slow down, and so this kinetic energy final goes to work out. Okay, so when I say how does the work in compare to the work out, it's the same as saying how does the initial kinetic energy before the collision, that would be this guy's kinetic energy, because this guy has none, how does that compare, boom, there's a collision, to the kinetic energy after the collision, and they hit each other. Okay? Do you think it's the same, or do you think something's lost? Remember the time I started with two carts, and they came together and stopped? Was kinetic energy conserved in that collision?